Hello students. So we are considering this problem or solving this problem on one dimensional bar element. So here we are having a step bar having two elements. Uh, the bar is fixed at both the ends. So what is given in the problem, we will say find the stresses in the two bar assembly which is loaded with force P and consider as the two ends as shown in figure. So we can have this one dimensional bar element. So for element number 1 we have some value, and for element number 2 we have some value that is in the form of 2a E upon L, because here area is given as 2a for element number 1 and area is given for element number 2 is a. The length of both bar is L and it is same. So P force that is acting at node number 2, and node number 1 and 3 are having fixed points. So we can have the element stiffness matrix K1 is equal to 2EA upon L, 1 minus 1 minus 1 1. So now we can have this two elements 2 by 2 matrix. The element 1 that is corresponds to the node number 1, so we can indicate as U1, and element number 2 it is indicating the node number 2. So 2 by 2 elements are matrix is given for the one dimensional element having two nodes. So K2 is also having same thing, EA upon L, 1 minus 1 minus 1 1. So how to convert this into finding the global stiffness matrix we will see. So here we are imagining the frictionless pin at node number 2, so that we can see we can assemble the global stiffness matrix, and here we will solve this simultaneous equation. So K into U is equal to F, that is it is in the form of equilibrium equation. So first we have this global stiffness matrix which has came from this two element stiffness matrices. Okay, so this one element number 1 is giving the values of u1 and u2, and k2 is giving value of u2 and u3. So there is a common point over here, it is u2. So u2 of element 1 and u2 of element number 2, that will be added over here because both are common. So as we are having three nodes for this problem, so global stiffness matrix also will have 3 by 3 matrix. So there may be values of three nodes, so it is having 3 by 3 matrix. So we are having here, so as element number 1 is having multiplication factor 2. So 2 has been given over here as E upon L is taken as common. So 2 minus 2 minus 2 3. Why 3 is 3 has came here, it should be 2, but the element number 2 is having 1 as a first element, and it will be added in the previous u2 previous one dimensional unit, what we can say, it is for the node number 1, node number 2. So both values are assigning for the node number 2, so it has been added. 2 plus 1 is equal to 3. So u1 u2 u3 are the values of dimension displacement corresponding to node number 1 2 and 3, and is equal to f1 f2 and f3 are the values of force which are corresponding to the node number 1 2 and 3. So we are applying the boundary conditions over here. U1 is equal to u3 uh, both are treated as 0 because both point are having the fixed uh, degree of freedom. So at the fixed point there may not there is not having any type of deflection, so we are considering deflection at node number 1 and 3 is equal to 0. So it has came u1 and u2 u3 is equal to 0, and f2 force is applied over here and it is equal to p, and f1 and f3 are the reactions which are coming because of the fixed nodes. So here we are having the updated equations. So here the K matrix, that is stiffness matrix, and the displacement matrix are in multiplication. So if we are multiplying these two matrices, the values which are given in displacement vector, that is 1 and 3 positions which are placed as a 0, and this multiplication factor will definitely give only the 0 values. So with the help of the elimination matrix we can delete this first row and first column and third row and third column, because these cannot have the participation in the calculation because it is given as 0. So only the value 3 will remain. Okay, so center value, okay, second diagonal element, that is 3, will be remaining and it will be multiplied to u2. So here as given we have ea into 3 divided by L into u2 is equal to p. This is the equation what we have observed over here, or what we have got this, and this will give you the value of displacement at node number 2, that is equal to PL upon 3 EA. So again if we consider the same equation for further calculation of stresses, then we can have E sigma 1 is equal to E into epsilon 1 is equal to B1 U1. What is B1? It is the value over here, it is given as E upon L minus 1 1. Now it has given and multiplied this L 1 by L to the both elements, and multiplying with u vector, that is u1 and u2 are corresponding to element number 1 only. So as we can have this calculation, the final value of stress will come P upon 3a. So similarly stress in the element 2 will be equal to P upon 3a. So here we can indicate this as a bar 2, that is element number 2. This is given or which has came the value of in negative manner. So this negative sign will indicate that the bar 2 is experiencing the compression force, because obviously we can see the in the equation, or so we can say in the diagram both ends are fixed and a force is acting on element number 2. So obviously it is trying to elongate, but the restriction is given over here, so that the compression force is applied over here. So we have seen this solution of this. So we may get many problems with the help of some value which are given for p1, or any different type of problems we will take. So now we are taking break over here, and we will see further problems in next video. Thank you very much.